So we're going to talk about a lot of different terminology in this lecture, and we're going to talk about all the different software qualities, or different qualities a software should have. So we're going to go and title this Software Qualities. Now, software, there are two different qualities when you're talking about software. First, we have our external qualities. And what external qualities are, they're pretty much just qualities that are visible to the customer or the end user. So visible to customer. And then next we have internal qualities. And if external qualities concern the customer, we can pretty much just say, or I guess intuitively figure out, that internal qualities concern developers. Now, what are some examples of these qualities? Well, I'm just going to go over a few different, I guess, vocabulary words, if you would call them that, and then we are going to kind of define what these mean within a software perspective. So the first one is going to be correctness. Actually, let's go ahead and change our colors here to, let's use a nice red. We'll leave correctness as blue for now. So what does it mean when a software is correct? Well, that means it satisfies its functional requirements. So we're just going to say that if a software is correct or has the correctness quality, then it satisfies requirements. There you go. And then another thing we can call a software is reliable. So we're going to use the when you're talking about software qualities, use a lot of nesses and abilities. So we're going to call it reliability. Now, reliability means if a software is reliable, it means it has a low probability of, I guess, failing. So we're just going to call reliability as the probability of a down system. Or I guess a system failure, if you could call it. So we're going to say that reliability is this. If you have a very reliable system, you're going to have a low probability of a down system. So your system is always going to be up and running if it's reliable. Another quality we can have is robustness. Actually, I don't like how it's a lot of red, so we're gonna put the words in red and then the definitions in blue. So robustness means that the software operates or has a desired outcome given unforeseen circumstances. Hopefully I spelled that right. Circumstances. So what that means pretty much is, so these unforeseen circumstances can be anything from faulty input to not having a Wi-Fi connection, etc. So when we think about robustness, we're thinking about how well our software reacts and works when it gets in a situation that wasn't accounted for. I guess the unwanted input could extend to malicious input as well. How does your software react to attacks or security breaches, etc.? Another vocab word that we're going to talk about is dependability. One thing you're going to find is that a lot of these words seem that they would be very similar, and they are, but they have a few subtle things that sets them apart. So what we're going to do, we're going to talk about dependability is pretty much just the fitness of or for intended use. So pretty much think about dependability as, no, I said I would change that to blue, but I totally forgot. Dependability is these three kind of put together. It has elements of correctness, reliability, and robustness. And these three qualities kind of give you this fitness test of how well your software works under intended use. And let's go ahead and get a new page up. So another software quality we can have is performance. Then we're going to switch to red. And performance, we can pretty much just think about how it efficiently uses resources. And these resources can be anything from data, it can be memory, it can be time efficiency, etc. And then the next software quality we have is usability. So what usability means, just the expected ease of use. So usability is just how well can your client or your customer or your users use your system. This pretty much concerns the user interface and your architecture, etc. Then our next software quality, I accidentally switched my colors, give me a second. I guess we're just going to switch to this blue, a little bit darker, and then we'll have this red. So we're going to talk next about verifiability. Now, what verifiability is, it's pretty much I want to avoid using verifiable in the definition, but the best definition for how easy the parts of your system can be verified. So verifiability is just pretty much saying this works. I mean, we integrated it well and the requirements are met, and verifiability just determines how easily you can verify your increments or your modules depending on which software development lifecycle model you're using. The next one is maintainability. Now, maintainability is concerned with scaling, so how well can you scale the system after it's been completed, as well as maintenance. Naturally, as you can imply from the name, maintainability. So how well can you maintain the system after you've delivered the final version? And one thing, a little tidbit, a little fact, maintainability, so the maintenance of your system, is going to be around 60% of the entire cost of the system. So this maintainability is a very important quality concerning developers. So it's that internal quality we talked about. And it's very important because if you can have a high maintainability, you can minimize your maintenance costs. And that really helps, sell the system to your customer. Next, we're going to talk about reusability. Making sure I spell that right. Ignore that, that's I-L-I-T-Y. So reusability is how well we can use existing products or components later on. So how well code can be recycled. So it's like having an invoice system and maybe the payment module or increment. Can we reuse that in another part of our system? Well, if it's an e-store with several different, stores, you could reuse that very easily. How well code can be reused for similar or different functionalities. And then the next vocab word we're going to talk about is portability. And portability is pretty much just how well your system, how well we're going to call it, can be ran on different environments. We're going to abbreviate that as diff, then we're going to abbreviate that as environ. So pretty much if you're developing, I guess, solely for the Mac operating system, you're not going to have a very high portability when you try to run it on a Windows or a Linux system. That's pretty much all that portability is concerned about. So we're gonna have to make a new canvas here because I want to talk about 2 more vocabulary words. And this first one is, we're gonna switch to red for the text. Understandability. Now, what understandability is, it's, as the name implies, it's just the ease, or the ease of understanding the software. Abbreviate that, understanding the software. And we can have a high understandability by having clean code, by commenting our code. So this is concerned with developers, so it's going to be a internal quality. So pretty much just comment your code well, structure it well, so if another developer gets assigned to that project, they can see that and understand what you were working on. In the next one, in the last one we'll talk about in this lecture, is sorry, I'm just having a little bit of struggle here. Interoperability. It's a mouthful, no doubt. Maybe if I saw the whole word. Interoperability. So what interoperability is concerned about is the ability of a system to coexist and cooperate with other systems. So it's pretty much, imagine if we had a university portal here. So this is our university portal right here. And within that university portal, let's say students need to be able to enroll in classes. So we have our enrollment system here. And then we have, let's just say they need to have almost like a student store or payment option so they can pay off their student account and all that. So we have a payment system and an enrollment system within the larger university portal, student portal system. So interoperability would be how well these systems cooperate within this bigger system. Now, we're going to go back in to the earlier ones, and we're going to switch our color to, let's just go with this bright green, and we're going to label all these different qualities as external or internal. So correctness satisfies requirements. This may, I guess you can consider this both external and perhaps internal, because it does concern developers. So, and it's also visible to the customers, but I'm going to go ahead and say that this is more internal than external. Reliability, this again concerns customers because of the low probability of a down system. Robustness, visible to customer. I'm going to go say this concerns developers more because the customer might not always recognize this. Dependability. And then I believe dependability in itself we could probably label more as an external quality because the customer is going to be able to see how dependable your solution is. Performance, the efficient use of resources, I'm going to go ahead and label that as internal because a customer might not always be able to see how well system resources are being used. Usability, that's going to be an external quality. Verifiability, That's going to be an internal quality. Maintainability is going to be something that also concerns developers. Reusability also concerns developers. Portability, this could be external. I'm going to probably leave it as internal because I think it concerns developers more than what it'll be visible to customers. Then understandability, naturally that's going to be internal. Then interoperability, this also concerns developers. I might go as far as say it's more external, because if they're trying to develop a